So in the previous video, this is where we left off. And it was this picture of these sample vials. And in each vial, I have collected a component of a complex mixture. And I was allowed to do that because the column and the stuff that I put inside of the column began to separate something that was very complicated in the beginning into its individual pieces and parts. So we took a look at a picture that looked very similar to this, and this is basically me looking at the column and me seeing the color separation that begins to take place that we call chromatography. Okay, well, what does chromatography really look like? Well, it really does look like this. And in actually one of the labs that we do in the chemical technology program, when you take the chromatography course, which is the last class of the program itself, we make you go through an extraction process of tomato paste. So we will bring canned tomato paste into the lab. You will take a sample of tomato paste, and our students extract a compound from the tomato paste called lycopene. And lycopene is a very hot word, and the reason is because it's good for your health. So if you take a look at a multivitamin, mainly for the women, we add lycopene to a multivitamin because it is shown to improve your health, your heart, your liver, your kidneys, everything that goes on inside of your body is somewhat improved by higher lycopene concentration levels. So our students extract the lycopene from tomato paste, typically found in tomatoes, but we would need tons of tomatoes to get something that's workable that we can measure. And then they go into our lab and they measure how much lycopene was in that sample. And they do that through this process. They don't see green, they see red, oranges, and yellows, but they don't see the green color. But it's still something that they can see, separate, and collect. All right, so this is what chromatography looked like back in its very early days, what I would call old school method, right? So here we see a very excited laboratory worker, right? I mean, look at his face. He's happy to be there. And then in front of him, if you look closely, you're going to see a really tall piece of glass, and it looks like a tube. And inside of that piece of glass is this stationary phase, or this solid that he has filled up to the top. So he has probably put a sample into the bottom, or into the top, and he's collecting the components out of the bottom as they come off. The problem, though, is that he really has to sit here on this stool the entire time that this runs, because it's his job to constantly stare at this piece of glassware and watch these things separate as they travel through the column, so that way he can collect them down here at the very bottom in his vials or containers or beakers, whatever he has to collect them in. So this is a very labor intensive process. So labor intensive that they felt sorry for this man and made sure that the chromatography setup was right beside of a window. So that way he can at least look out of the window while he's staring at the column all day long and look at the sunshine and wish that he was maybe out there instead of in a lab. Okay, but that is one of the setups of the early chromatography experiences. Over here to the right, you're going to see another picture, but the reason that I like this picture is because it shows you that the columns do not have to be small. The tunnels that I put these compounds in can be bigger than me, bigger than you. So if I look at this picture, this is huge. This column starts up here, it ends down here at the bottom. It's super wide, it's super tall. It's still filled though with a solid, and this person looks like he's pouring sample or maybe more liquid into the top of the column, and that's traveling through the column itself. And then down here at the very bottom, you're going to see a huge jug that he's going to be collecting these compounds in. So these are very old pictures of what chromatography used to look like. But we're better than this. We no longer have to go through this particular process in the field of chromatography. Now, we can still do hand chromatography. And when we do hand chromatography, we have a couple of different columns that we can use. And that's what we call those. We call them columns, chromatography columns. And this is particularly used for hand separation. If you're not using an instrument, you would use one of these. The problem, you also have to rely on your eyes in order to separate. So here we have one of our most common chromatography columns. So here's a chromatography column. It's very similar to what we would call a burette. The difference is that a burette would have tick marks on the outside because volume delivery is very important. This doesn't have any tick marks. Volumes we're not really concerned with here. So this is a chromatography column. This is what we would call a stopcock at the end that allows me to control the flow. So I can cut the flow off, or I can open the valve up and allow the fluids to travel through the column and drip out of the bottom. And if you look really closely right here, this is what we would call a frit. F-R-I-T, frit. And the frit is just really a piece of filter that prevents all of the solid stuff that I fill this column up with. It prevents all of that from getting down in here into the valve and into the tip of the column. It's just a barricade. That's all that that's for. It allows the liquid to escape through, so it's porous, but it doesn't allow the solids to go through because I don't want to clog this end of the chromatography column up. Well, the chromatography columns can come in many different forms and many different sizes. Over here to the right, you're going to see a little bitty baby chromatography column. So here's a little short one. Does the same job. Maybe I can use a short one. If I use a short one, the times are probably going to be quicker. I don't have to wait as long for those things to separate off. That's why I can use a short one. And then here are some big ones, big fat ones. So these things are huge. It takes a lot of stuff to fill up these columns with. And that probably means the separation is going to take very long. Hours, maybe. And then here you can see the frit maybe a little bit better. So here's another frit, and again that's porous, so all the liquid will be able to escape through. But this is the barricade that keeps all of the solid gunk up here at the top and doesn't stop up the other ends of the column itself. Down here at the very bottom, you're seeing another similar to the very first one that we discussed. But the difference here is that this one has a big bulb up at the top. You can kind of see that. We call that a well. So this bubble of glass that's up here at the very top of the column, that allows us to put more liquid into the column because the liquid pushes the stuff through. And I don't want to stand there and just keep filling it full of liquid all day long. So modifications of the columns have came out now where I can have a well. And this allows me to put more liquid into the column, and that way it can slowly take what it needs and slowly push these compounds through, and I don't have to fill it up as much anymore. And then finally, here is another column, and this one shows you multiple color bands that are separating in the column itself. So here we see maybe a black and a beige and a blue and a green and a red and maybe a khaki color, but here you can see the color banding that's taking place throughout this process. We still have the large columns though. Here's proof that we still have the large columns. And if you look over at Miss Vanna White of the chromatography world, she is showcasing this huge big column that she's got on rollers. These things do tend to be heavy. So if you're working for a company that uses a hand column, such as this one, once you fill that full of the solid stuff that goes on the inside, these things can be super, super heavy, hundreds of pounds even. And we don't want people breaking their backs lifting heavy stuff all day long. So we put them on rollers, and then down here at the bottom there'll be an escape outlet with a tip that we can just put a collection vessel up underneath and collect the compounds as they come off one by one. So that's the story, maybe some pictures of the columns itself that are used today and how it compares back in the early 1900s. Here's Mr. Tisviet's gravestone. And if you take a look and translate what's on his gravestone, it says, he invented chromatography, separating molecules but uniting peoples. Ah, isn't that sweet, right? So basically what this is saying is that he spent his career literally improving science because this was the first step in separating components from each other, almost like segregation in a way. You're separating one group and you're keeping that group together, and you don't want it to interact with the other groups that are there. Well, through this process of separation, what happened is that the whole science community, no matter what country, no matter what state, no matter what background that you're from, coming together and loving each other because this was such a wonderful technique that has been discovered, and he has united now the science field in itself. Botanists can now use it to their advantage. Chemists can now use it to their advantage. Biologists can use it to their advantage. Anyone in science that has to deal with a complicated sample or mixture can now use a process like chromatography in order to do the job. So he united the peoples. How sweet. Okay, so again, color is no more. No longer do we have to base things on color or color banding. We now are better than that. We have came a long way since Tisviet's studies back in the day. And in the next video, we're going to expand our knowledge of chromatography now. And we're particularly going to look at the field of HPLC. So once again, stay tuned. If you want a potty break, maybe now's the time to take one. But come back.